a new video. I stopped it after 20 minutes. So the notation, they're all the same, and I will always try to simplify this function if I can. Remember, factor and simplify are our key concepts in any math class. So I'm going to work on the function and rewrite it as x to 1/4, because the fourth root of x is the same with x to power 1/4. And I'm going to rewrite 3 over x as 3 multiplied by x to -1. So 1 over x is x to -1, to refresh our memory on those two. Okay, so now I will differentiate. Bring the power in front, subtract 1 from the power. 1 over 4 minus 1, we know it's -3/4, so power -3/4. I bring the power in front, -1. I have to multiply it by -3. -3 times -1 is +3. And I have to subtract 1 from the power. This is it. You can rearrange it a little bit if you want to. Bring this to the denominator, bring this to the denominator if you wanted to. So this is the fourth root, so let me write it again here. X to -3/4 is 1 over x to 3 over 4, which is the same with 1 over the fourth root of x to the third. To refresh our memory, the numerator is always the power, the denominator is always the index. So this will be the fourth root of x to the third plus 3 over x squared. Get used to something like this. Many problems in this book are kind of extreme. Kind of. Very good pick. Anything else you would like to pick from here? I would like to pick 36. Obviously, you don't want to use the definition of the derivative on a function like that. I guarantee you don't. So 36 caught my eye on 145, in which I have f of x equals 4 over 7x to the third. And yes, of course I'm going to rewrite it as simple as possible, getting it ready for differentiation. So now when I determine f prime, I bring -3 in front, multiplying it by this, so I get -12 divided by 7. Subtract 1 from the power, and now there is no problem. I can bring it back to the denominator. And this is it.
So question, how did you get from -3 to -4? How did you add it?
So how we got from this?
Yeah, sorry.
No worries, no worries, no worries, no worries.
I didn't come in until 20 minutes later.
No worries, no worries. So on page 4, when I post this later tonight, page 4, bring down the power. It becomes a factor in front, factor meaning multiplied, and we subtract 1 from the power.
Oh, okay. Okay, I got it now. Thank you.
Thank you. Other questions here, please? Anything else? Would you like to choose the next, or I will?
Can you do,
We can move on to page 146 when you're ready.
can we do like one more on page 145?
Yes.
29?
Number?
29.
29 it is. Very good. And 29, where are you, 29? Yes. So we have the function 5x squared minus 7x plus 3. Very good. So Maybe I should have mentioned here on this list that, of course, the slope of x is 1. So when I differentiate, I get 2 times 5, which is 10x, minus 7. The slope of negative 7x is negative 7. The slope or the rate of change of 3 is 0. Okay, I would like to look at, I'm on page 146. Feel free to choose the next, and then I would like to look at word problems. But I'm not rushing you. You can choose anything. But I would like to choose to work on 54. So this was still on 145, and this is on 146. We are given y equals x to the third plus 2x minus 5, and we're asked to find dy over dx, and there is a bar. It's a very useful notation, x equals negative 2. What this means is, once you find the derivative, once you find the function and you're done, evaluate it when x is negative 2. That's all it means. This is it basically like saying find f prime of negative 2. That's the same thing. So when I find, go ahead.
So we're just basically plugging it back in.
That's it. Getting the exact slope at that point. Because the derivative, which is 3x squared plus 2, will give the derivative, will give the slope of the tangent line at any point. Because the function is continuous and it is differentiable everywhere. But we're specifically interested when x is negative 2. So then this is the same with dy over dx. Sorry, dy over dx. And now dy over dx, evaluated when x is negative 2, will be 3 multiplied by 4 plus 2 is 14. So at this point, if you say, find the equation of the tangent, find the equation of the tangent line to the graph of y at p negative 2, then I will do this. Y minus y1 equals the slope times x minus x1, where the slope is 14. And x1 is negative 2. How do I determine y1? Can anyone tell us how to find y1? Very good. This value must be y evaluated at negative 2. So f of negative 2, which is negative 8 minus 4 minus 5. So I think that this is negative 17. So then this is negative 17. So I will determine the equation of the tangent as y plus 17 equals 14, x plus 2. I distribute 14x plus 28, but minus 17, because I move it to the other side. So y equals 14x plus 11. What does this represent? It's the equation of the line, of the tangent line, to the graph of the function at this point with x negative 2. And I was able to determine the slope using the derivative, evaluating it at negative 2. Any questions? Any questions? okay, I would like to, would you like to choose something else? If not, I would like to choose from 61 through 78. Feel free to do so. If not, I will. Okay, let's say 78. In 78, we are asked to find the points on the graph at which the tangent line is horizontal. Find points on y equals, or f of x equals, same thing, 1/3 x to the third plus 1/2 x squared minus 2, where the tangents are horizontal, or if you want, horizontal lines. How do we approach this problem? What do we need to do first? What do you think? Any suggestions for me? Any suggestions? Anyone? How would I approach this? Well, obviously, when a function has a horizontal tangent, the tangent basically has a slope of what?
0.
Thank you. So all I have to do is find y prime and eventually set it equal to 0. So I bring 3 down, it cancels, it simplifies the 3, so I have x squared plus. I bring 2 down and it simplifies with 1/2, so it's plus x. And when I differentiate -2, I get 0. So now all I have to write is that x squared plus x equals 0. Yes, I do have to factor out x. And I get 2 options. From here, I get that x is 0. And from here, I get that x equals -1. It's guaranteed that at points P and Q, 0, -1, oops, I didn't mean that, of course, the tangent has to be horizontal, because that's how we determine them. So knowing that, and since we're asked to find the points, I have to have the y-coordinate. When I plug in 0, that's an easy task. I get -2. When I plug in -1, I have -1/3 plus 1/2 minus 2. So f of -1 is -1/3 plus 1/2 minus 2. The least common denominator is 6. This needs a 2, this needs a 3, and this needs a 6. -2 plus 3 minus 12. -14 plus 1, -11 over 6. -11 over 6. Any questions on this problem, please? Anything? Do you want to say anything before we look at more problems? Since we're facing temperatures and illness and everything, I know you should say, I don't want to talk about it, so why would you choose that? Let's choose 88. On page 147, please choose the next when you're ready. Temperature during an illness. The temperature T of a person during an illness is given by T function of time temperature function of time as negative 0.1 t squared plus 1.2 t plus 98.6. This function is given to us where t is temperature in degrees Fahrenheit and t time in days. I take notes when I read a problem. Find the rate of change of the temperature with respect to time. Part A, rate of change of temperature with respect to, this is how lazy people write with respect to, time, is T prime of T. So negative 0.2 T plus 1.2. So this is the function that gives the rate of change. This is a quadratic function. It doesn't have a cusp, vertical tangent, or a corner. It will be differentiable everywhere. So this exists everywhere. Name t and we'll be able to find it. Since t is time, we should not go to the left of 0, of course. But find the temperature at time 1.5 days. That's not a problem. So the temperature T of 1.5. I'm sure you already know my habits. I prefer putting the function in. Who knows, they may ask me to evaluate again. So why not? Let's have the function in here, negative 0.1. We don't have t in the calculator, we have to use x, plus 1.2 x, and plus 98.6. And then second, and the table, I will plug in 1.5 and see what happens. So the temperature is 100.18 degrees Fahrenheit. Please remember the measurement unit at all times. Find the rate of change. Rate of change of temperature with respect to time at 1.5 days. Of course, it will be T prime of 1.5. And that will be negative 0.03 plus 1.2. So you can, if you don't trust me, is negative 0.2 multiplied by 1.5 and then plus 1.2. So the rate of change is 0.9. What does that mean? And what is the measurement unit? It's negative 0.3 plus 1.2, so that's 0.9. Measurement unit, before we move on. Measurement unit for this. Anyone? Rate of change of temperature with respect to time.
Fahrenheit over time.
Excellent.
Per day, sorry.
Very good. So it means, because it's positive, what will be the interpretation? That according to this disease, assuming that this is the model for the temperature for in this particular illness situation, it appears that the temperature increases by almost a degree, 0.9 degrees Fahrenheit per day. Any questions? Any questions on this? Okay, let's learn about blood flow resistance. Oh, I'm sorry, forgive me, I said that you would choose, if you want. If not, I will.
You can do that one.
Okay, very good. 90 on page 147. Let's see. we're given S of R equals 1 over R to the 4th power. The equation can be used to determine the resistance to blood flow, S, of a blood vessel that has radius R in millimeters. So R, radius, in millimeters, mm. And S is resistance. The graph is even given to us. If we want to, I can copy it for you. Of course, it's undefined at 0, and there is no blood vessel of 0. So the graph is 1, 2, 3, 4. So something like this. So this is S equals S of R equals 1 over R to the 4th. Okay. Find the rate of change of resistance with respect to R, the radius of the blood vessel. Rate of change. What do I have to find in order to find the rate of change of resistance with respect to R, radius? What do I have to determine?
You have to determine the radius first.
Is the rate of change.
Derivative?
The derivative, yes. Is that clear, everyone? Now, of course, I like to make my life easier every chance I get. I don't want to do that. I want to do that. Differentiate this. So negative 4, R to negative 5. And yes, now I can go back. Good. Part B. Find the resistance at R equals 1.2 millimeters.